All right, decide whether Rolle's theorem can be applied to this function. And full disclosure, you do not have to know Rolle's theorem for the semester test because you don't have to know it for the AP exam. But Rolle's theorem is just a very specific case of mean value theorem, so it's still fine to review it. But mean value theorem says that the instantaneous rate of change is equal to the average rate of change. So that would look like this if we're going from -1 to 3. And then what's specific about Rolle's theorem, the one instance that makes it Rolle's theorem, where we might call it that instead of mean value theorem, even though it's mean value theorem, is Rolle's theorem only works when your average rate of change is 0. So when all of this equals 0, and of course your fraction only equals 0 when your numerator equals 0. So if we plugged a 3 into this function, we would get -81 minus, I don't know, I can't do that without a calculator. Numbers are too big. Well, I mean, I guess I could, but I don't want to take that one. So plugging in 3 into the function gives you 10. Plugging in -1 into the function, if you're doing this with the calculator, make sure you have parentheses so that it does the order of operations correctly, is 10. And so I don't really care what this denominator is, although I guess it takes 2 seconds to do that arithmetic. But it looks like the average rate of change is 0. So I would say yes, Rolle's theorem can be applied here. Okay, and then so since the answer to that is yes, find the values of C that make this true. So if all of this equals 0, where it would occur, mean value theorem says that there's one instant, or at least one instant, there could be more than one, where this happens. So that would be first derivative. So power rule a bunch of times, and then we need to solve this. Looks like we could factor out a 4 and an x. This is the derivative. This side of the equation's the derivative of f. So I just did the power rule to f. Okay, and then when we factor, just because you take out a GCF, factoring is usually only helpful if you factor it completely. So factor completely. And so it looks like the average rate of change is 0, which is why you could call this Rolle's theorem. It's equal to the instantaneous rate of change, and if you want to know when that is, set the instantaneous rate of change, also known as the derivative, equal to that average rate of change, and then solve. So it looks like when x is 0, 2, and 1. There's 3 places where that graph has a horizontal tangent line. So if we graph this guy too, then you can kind of see what they're asking you to find. I guess I even restrict the window. Okay, so on the right side of mean value theorem, the instantaneous rate of change. There we go. So this would be the average rate of change. So we figured out that that was 0. And because this is continuous between those numbers and differentiable between those numbers, it's not jumping around here, we knew that it had to have that same slope at least one instant. And so from the algebra, we figured out that it had the same slope at x equals 1, x equals 2, and x equals 0. So that's what we were searching for. Okay. Looks like we got just a couple minutes here.